In many manufactured products, it is essential to join two or more elements or surfaces together. There are many methods that can be utilized to join parts, such as welding, riveting, adhesive bonding, and bolting. Bolted joints are the primary method used when two or more elements need to be disassembled and reassembled without destroying the joint. Bolted joints can be classified differently based on the materials used for the joint, the structure of the joint, or the type of fastening method used for the joint. Bolted joints can be classified as soft bolted joints or hard bolted joints, based on the material used for the joint. A soft bolted joint is a type of bolted joint where the hardness of one of the elements is below 30 RC, while a hard bolted joint is a type of bolted joint where the hardness of all of the elements is greater than 30 RC. An example of a soft bolted joint includes a gasket that is placed between two pipes. A gasket is a soft compressible material that provides a seal between two pipes and prevents leakage. Examples of hard bolted joints include a wheel assembly and a bridge girder. When identifying a bolted joint based on the structure of the joint, it can be classified as a single lap joint, double lap joint, or butt joint. The final way to identify a bolted joint is to examine the way the elements are fastened together. This method includes using either a through hole or a tapped hole. A through hole, sometimes referred to as a stud joint, relies on two parts of similar thickness that are joined together using a stud. Through holes are typically used where frequent repair or removal may be expected, such as a pipe flange. The tapped hole, also known as a screw joint, relies on a threaded hole and a threaded fastener to secure a small part to a larger part, as seen in pieces of machinery. Regardless of how a bolted joint is classified, all bolted joints consist of some common components that include a bolt, nut, washer, and two or more elements. The main objective of a bolted joint is to maintain the cohesiveness of the joint, whether it is a tension joint or shear joint. A tension joint will try to pull the joint apart, so it is critical to have the bolt act like a clamp to hold the elements together. In a shear joint, the elements will try to slide in opposite directions, so the objective of the bolt is to act like a pin that keeps the elements stationary.